Thank you. So this is 2016, so I think it's more than doubled at the moment. And yes, the rule is like distinct caps, and I have to drink it, because if not, like I go in any bar and say, give me all your caps. I'll take them home, and that's easy. I need to drink them, and they need to be different. So I'm a Belgian lover, you might notice somewhere. All right, but that's not the topic, although it's nice. So I work for Droid Tech. Yeah, sorry. Sorry, say it again. The drinking game. No, there's no drinking game now. Yeah, but we can invent one. Oh yeah, the timer. So I'm Renzo at Reborg, at Twitter, and other social networks. I work at Droid Tech. Is a software house in the financial regulations space. So we take regulations which are normally written as PDF documents and stuff like that, and we make them into machine-readable and processable code. And you can call a service and ask, can I do this, can I do that? And it's kind of an interesting challenge. It's mainly a Clojure shop, but there are a few other functional languages used, and we are expanding in other areas, namely formal verification. And we are hiring, so if you are interested in some of what you are going to see on these slides, come and talk to me. I'm happy to talk about it. I'm also organizer of the Papers We Love London. It's a very nice meetup where we we read a paper every month and we discuss it together. And a few other things like the Clojure pills. And I have also this library that I want to plug in here to do parallel programming in Clojure. All right, so we know the basics already. We're not covering all, today like the basics of Clojure. You might know about persistent data structure. You might have heard of that. JVM, interoperability, concurrency, and stuff like that. Macros, it's a Lisp, and so on. What I want to focus on is like a little bit of retrospective. 11 years from now, it was kind of the first release of Clojure. I just want to understand what happened, what was successful, what was not, in terms of library tools, ideas, and also review them and understand if there is a commonality and how we can, what we can do in the future to be more successful as possible. So the list is long and is subjective, and will probably I will forget probably some very important thing, but there are so many, so I had to make a choice. A word about the examples and demo we're going to see. I'm mainly searching for the principles, so sometimes I'm just showing you like the very raw core of an idea or a library is not the latest version. You have to go like to the library page and use the actual version, because I'm looking into like the first commit or the very first few commits to understand how they work. So hang tight, there are going to be a lot of them and a lot of code to see. So 2008, 2010, the origins. I'm going to talk about these four here. So I divided them and split them into 4 groups, roughly. So we're going into the details now. So we start with Composure. So it was 2008, so essentially Clojure was just out in the wild. And Composure was the first, not the first web API, but the first web API that took traction, that people appreciated, and it was inspired by other libraries in the Ruby world, Rails and Ruby. And we can see that we are going to start to see now a trend in successful libraries. They are almost always DSLs. And you can argue that every program is a DSL. It just depends how much is formally specified or not. But some of them are more DSLs than others because they actually put that in a document that you have to read in order to understand how to use it. And this is one of them. So you got this uppercase get, which is a macro. And it takes parameters and is doing like a nice deconstruction of them. So if you want to read like a parameter from the GET request, you just mention it as X and Y, and you're going to get it, like you can use it in your code. So you don't need to do any of those, like take a string, pass it, where is the question mark, where is the equal sign, and so on. And is doing that kind of thing, is using a macro to do that. I'm going quickly, sorry, I'm going into the details of all of them. Leiningen, the first successful building tool. And we are still using it today heavily. And there are different options nowadays. But I think Leiningen was the first heavily successful one. And you can see again the concept of DSL. We are taking the meaning of a project, what is a meaning of or creating a project and doing a project in Clojure is metadata about the project. So you have dependencies, you have to depend on libraries, you have to depend on some version, and you declare where is your home URL for the project and stuff like that, and many more that is not in this slide. And moving on, Cascalog. This was why it was quite interesting when it came out. What you see there is another DSL, but it's implementing. It's an implementation of Datalog that you might have heard of, and we're going to see more Datalog after in a specific demo. So I'm not describing it now in details. But what's happening there? This is driving a MapReduce task on a Hadoop cluster, which is kind of an amazing thing. It's doing word count with those lines. And this thing is creating the MapReduce task for you, is sending them to the cluster, results are coming back. This now is not as much used as it used to be, and the reason is because MapReduce kind of decreased in popularity, favoring other kind of technologies that are more streamlined and are not like batch-like. But MapReduce is still used in many places. So the library is still there and usable, perfectly usable. Core.Logic. This is an implementation of a relational program or a logic program, which is similar. So it's the same family of Prolog, but not exactly like Prolog. So it takes a different approach for unification and substitution. And specifically is mini-canren. So it comes from Scheme and Racket community, and somebody in the Clojure community decided to, that's a nice idea, let's have it. And also historically, Lisps in the past, they used to come in their library with a Prolog implementation embedded in them. So, and if you go back like the beginning of Lisp, you might notice that there's not such a great, such a sharp distinction between logic programming and functional programming, or it was smoothed out because, I mean, you know, Lisp came out to do reasoning, right, to teach computer how to learn. So there's a common root there. So there's a tradition of having a relational program or a relational programming way of expressing your program. And we're going to do a little bit of that now. And so bear with me. Where is it? Because I have the file saved here. All right, so we start the REPL down here. Actually, let me do another way, this way. Can you all see? Okay. Let me know if I need to make it bigger. So what we have here is like a normal function. So this function here called SomeRules is taking some input attribute, A, B, C, D, A. And you can imagine that somehow this is just a desugaring of like a more complicated English-based language rule set where you can say that A is, I don't know, some machinery is like reaching a threshold of 10, and another fact is happening that we reached also the number of given pieces we wanted to create. You can interpret those A, B, and C like facts somehow. And this is like a linear implementation. It's just taking, I'm just giving in to some rules, these A, B, C, and D, and E parameters. And this simple function is telling me true if, of course, I'm sending in the right values. If I'm sending in like -2, for example, for A, it's telling me, no, false, sorry, because A should be, you told me it should be equals to 10. Same goes if I remove A, is not present, so it's telling me, no, that's not true. So your problem is not solved, or your problem is solved. We can interpret false and true like that. So now I'm saying, what if I take this relationship between attributes, and I put it in a form so I can ask questions based on what the output is or what the input is, and doesn't matter. So I created this new sum rules, which includes some more syntax in it, as you can see. And I'm not going into the details of that. I just want to show you how it works. But what I can do is, implicitly, when I call these sum rules, I'm asking, what is the input that is making this problem solved? So you don't see the true appearing, but the function is implicitly saying, if I want an output of true, what is the input that I should put in? And it's telling me, of course, what I expect. A, B, C, and D should be 10, 20, and so on. And now we're going to start reasoning about this and adding a little bit more of complexity, if you want. And we can, if we add, that's a little bit of sugar just to recognize if the input is present or not, and not print you a nil, just printing you something more interesting. But by doing that, I can start to ask more interesting questions, like if I give you B20 and D40, what else do I need in order to make this problem solved? And is returning back something, and so on, right? So we kind of inverted the flow of a normal program, and we start from the solution, and we want to know what input is required. And if we take, for example, a more interesting problem that is, we put a similar problem, so we have a Sudoku puzzle, and the zeros are representing what I've missing input here. I don't know what should go here. So that is our A, B, C, and D. And I can create a relational program that is putting that Sudoku grid in relation with the output that I'm expecting. So I can ask, you can imagine what's going to happen if I do this, right? It's going to, well, if I evaluate the rest, right? So you don't see this in a single page, but it's usually a single page of code that I need to write here. I need to do a little more. And just want to show you that I can solve Sudoku in 30 lines of Core.Logic. And then I'll be happy. Where is it? Here. All right, got the solution. Yep, so those zeros are representing holes in the solution I want to achieve, and I'm asking the relational engine, what should I put in those holes? And this is a very good problem to solve with Prolog or a relational program. Good, let's move on because we have a lot more to cover. Where's the presentation? A few resources for you, and I take this little break to drink some sip of water. But so you might have noticed that our Wi-Fi is not like a normal Wi-Fi. So this guy, Sun Ra, in 1972, predicted that today the Wi-Fi was to be called space is the place. So space is the name of the Wi-Fi, is the place is the password. It's not coincidental. He's a musician and a futurist. Good to know. So let's move on. Let the fun begin. So more interesting things to see. So Miji was as a special place for me because when I started programming in Clojure, I had a little bit of Ruby and Rails experience, and I was doing a lot of tests first, and I was looking into BDD and those kind of stuff. So when I came around in Clojure, I found this framework which embedded all those concepts for me, and is a testing framework and is top-down. So it helps you with a top-down approach where you go through wishful thinking. You want to know, you have a program you want to write, and you start to write exactly how it should behave. And then you go down, and then you come up again, and you got the solution. So it's not easy to see here, but you got facts, and it's very textual. And again, you might see another DSL here. And again, it's all macros, once again. Well, Lisp is all macros. Clojure is not exception. It's got like 12 special forms. Storm, another interesting thing. So, MapReduce it was a good model for computation for batch-like processes, but there was a time where we needed more real-time analytics, and this is when Storm came in, and it was quite of a storm because I remember I never saw a model like that, but it's creating topologies of computation that are stream-like. So once you created your topology, there's data coming in a spout, I think it's called, and they're coming out a bolt or the other way around. So it's got a few funky terms. But again, this is still widely used today, and it came out from Twitter at a point, from Twitter engineering. And Palette is, again, like the take of Clojure into like DevOps, in DevOps space. So I cannot imagine probably a more side-effecting code than the one you see here, because when you execute this kind of stuff, you get AWS machines created and Tomcat deployed and HA proxy deployed as well. So use with care, but it's all made also for you to being able to test it locally quite easily. So it's developer-oriented, and then when you go to production, it actually does those things. Again, a little bit of DSL-ish, less macros that I can see off. And again, this concept of ClojureScript is quite old as well, and it was always something that Reach wanted to achieve at some point or another, to reach like to have a wide reach into many more platforms than not just the JVM. Because if you can run Clojure in a browser, then you can like reach a much wider audience. It was reworked in 2011 and like released officially in like about 300 lines of code. What is it? Because this is quite like a normal way to approach problems in a Lisp language, which is taking Lisp itself, because we are talking about taking Clojure, and this Clojure is driving JavaScript on the other side. We put Clojure on one end of the pipeline, and we got JavaScript on the output of this pipeline. And how do we do that? Well, we have a reader already and embedded in Clojure. We just need to analyze and emit the code differently. And we're going to see that in the demo, next demo. I go back here, ClojureScript, and here it is. Open up the file. So what do we have here? Let's start from the bottom, because there's a few, there's quite a lot of things at the top that maybe we don't really need to look at. So let's load this guy. And let's go in that environment and evaluate a little bit of stuff. So I'm going to evaluate this, and it's working as expected. So what you see here in this snippet, highlighted here by the cursor, is like a valid Clojure expression, is an if test, then do something. And it is not interpreted, is quoted, so the normal Lisp reader is not doing anything about it. And we analyze it, and we get this like long list of Clojure data structure, which is the representation, is called the AST. Is the representation of that Clojure expression into another Clojure. But this is decorating all that with what kind of operator is, and so on and so forth. And using that, if we attach this to like emission, we get what we expect. So what you see here at the bottom is this if statement transformed into JavaScript, emitting JavaScript. Then there is all the machinery to put this JavaScript, which is a string, into an actual browser. And this is what is making maybe the thing complicated. Then you have to optimize it, so there's a lot of work to do. But at the end of the day, ClojureScript is a parser for Clojure emitting JavaScript. Let's go back. Got 5 minutes. Yes. Okay. Not including questions. A few resources. So I sip a little bit of water. Have a look to see where do you see your language. So I don't know if you can read, unfortunately, because it's a little bit dark. But here at the top here, I think is where Clojure and Lisp are. So the vast typeless traps. It's not very positive. Maybe abstraction peaks is where like ML languages sit. Who knows where this picture is coming from? All right, it's an ML book. ML, only ML, not OCaml. It's the cover of a book, but without the title. On an ML book. Okay, let's go back because the time is passing fast. Going Enterprise Edition. Co-typed. So there have been an ongoing effort into like add optional typing on top of an untyped language like Clojure. Sorry, it's not untyped, it's not explicitly typed. And Core-typed is one of those efforts, and Core.Spec is the latest effort. But what this thing can do is creating a little bit of a compiler step where you can annotate Clojure with types, and the compiler is able to tell you there's a type mismatch here. It's not as powerful as like a type system that is baked in the language itself. It's optional typing, right? It's added on top. It's give you this possibility, and again, it's coming from scheme influence. EDN, we can skip this, so I have time to talk about other things. Reducers came around, and is the final definition of parallelism, the final specification of parallelism in Clojure. So everything was attached to a fold operation, which is a reduced underneath. The fact that it's called fold is because it's hiding a few things and that are making this code parallel. Datomic is another thing I want to talk about. I have 2 minutes, and codec. So Datomic is written in Clojure, and what we have here is the Datomic console. So it's a distributed transactional time-aware database that you might have heard of, which is written in Clojure. And what I'm doing here is, oh, maybe you don't see it very well. All right. What I'm doing here is trying a few queries to see what we can do with that. Datomic. There are the queries. Be patient. All right, let's grab this one. Most commits per author, for example. What I've done with this is I took the Git repo of Clojure itself, and I imported it into Datomic, commit by commit, with a tool that is called codec. And this tool is able to dissect every commit by function by function, definition by definition. So the granularity of this database is the definition of a function. So we can see when a function change instead of when a file change. And here we can see who's got the most commits in Clojure, and you might expect a reach at the top, of course. It's just a curiosity. And this is Clojure again. So let's go back. Almost there. Last break. I have 10 seconds. You might imagine what is the growth of the word exponential by time, and of course it is exponential. So introducing the the year where maybe most of the things came out. Lighttable. Lighttable is an editor for Clojure, and is Clojure and ClojureScript, and also other languages, and is written in ClojureScript. So this is a browser, and is very nicely done. It's also got this idea of evaluation in line that it's always on. So you type and thing gets evaluated. I'll skip this. I'm gonna skip OM component, Core.Async. So I might not be able to demo this. I'm just going to talk about it. So Core.Async is an implementation in Clojure of a few concepts about concurrency, and those are coming from ideas from F#, is here, inspired by F#, C#, and Scala, with sync await, and channels from communicating sequential processes, CSP. And what was innovative in this is that we use Clojure to create a state machine. It's like, again, another macro, another DSL, to create a state machine that emulates continuation passing, because we don't have that baked in Java, so we have to emulate it. And the result of that, I'm going to show you quickly. Core. How much time I have? I'm not sure. So, okay, so I'm rushing it, but without, huh? It says 10. Okay, I got confused by the colors. You also told me, but, okay, so we have time to see something in Core.Async, I guess. Where is it? Just need the file names. All right. So, Core.Async. I feel like restarting this. And we go at the bottom here. Cool. And I'll just show you something here, and then we'll go talk about it. So what we see here, so I was talking about this, it's implementing a concurrency language, essentially. So what this let us doing is this expression that you see here, which is an async block, which is followed by some other Clojure code. Inside this Clojure code, at any time, I can have these await calls that you see here, async await. And what this thing is doing is making, so this future call is creating a separate thread that is going off and doing some work. And what we want to achieve with this is that while this thread is going off and doing some work, we want still to have the control of knowing when the thread is done. And if we don't do this async await, we have either to sync ourselves, to wait for the thread to finish, or essentially not wait and do something else, but at that point it will be side effecting and stuff like that. I hope it's coming through decently. What this await call is creating is a state machine, so that that thread can go off, do some work, and talk back to the state machine and saying I'm done. And when that state machine receives the result, it can move on to another step. What we don't see here is like having an if statement, or having a try catch, or having a loop with awaits inside. So we need to linearize that, and once it's linearized, we can transform it into a state machine. And once it's a state machine, we can evaluate this. We are not hanging onto the thread that already started. You don't see it, but it's counting the 10 seconds. And when we can deref it at any time. What that is doing is, and you can see this, like it's not very readable, so I repeated the same code down here. What this await async block is doing is creating this state machine. So it's a big macro. And this macro is generating all that code that you see below. And that code is doing this await call and wait. Await call and wait, and linearize all the calls. And again, in order to do that, I'm leveraging the Lisp reader in order to read Clojure, analyzing it, and emitting stuff. In this case, it's not ClojureScript, it's a state machine. I think it's a kind of a common theme for the tool I'm illustrating here, which are the most powerful. All right. a few resources. So these resources are, then will be available online, and as for if you want to review all the things that we saw, you can go here and click. All right, we are arriving to the end of the presentation. The final few things. I kind of noticed that after the lot of tools that we had, maybe at the beginning up to 2013, there was not something I could see of the same like level of abstraction or same level of expressiveness or power. It might be me not seeing that. I'm not sure 100%. There were a few things, but they are less than they used to be in the past. So did we invent everything? Probably not. Maybe it's not a problem. Maybe it is. I'm not sure 100%. So the Clojure CLR, I put it here because I need to introduce Arcadia, which is coming after. It's an implementation of Clojure for the .NET environment, for the CLR. And it was there since the beginning. And a few, like one guy specifically, and his team has been maintaining this porting of Clojure onto the CLR for a long time, for 11 years. Well, a little less than that, but a long time. And I don't have a lot to show you because it's just Clojure. The only thing that happens is you can mention CLR types that are not in Java, like int32, and this gets then compiled into the CLR instead of the JVM. And when you have that, you can have things like Arcadia. Let me make this bigger. And so what you see on the REPL, the black thing, is code that is evaluating in the 3D space or the virtual reality space that you see in the background. So what these guys achieved is Clojure evaluating into the 3D space. And they can create shapes, they can do animations, they can do a lot of amazing things. So we could stay here for a while, I think, but I'll have to move on. It's quite nice to see. I saw the presentation a couple times. What's next? Transducers. I think it was one of the major pieces of innovation lately. And what they do, or what you see here in this example, is that we are taking the typical data transformation pipeline where we start from some items and we map on them, we transform them, we filter, we can do a lot of operation on them. And what transducers have done in Clojure is making this truly modular and truly reusable. We had a similar approach before, and it's still there, and it's still valid, using sequential abstractions. And this approach, though, is making those compositions that you see there, those comp, arbitrarily nested as much as you want. So you can essentially create your data transformation if you're in that space, and compose them as much as you want. Something that was not that flexible in the past. And not only, but you can also use this in ClojureScript, which is another big selling point for transducers. Same, I didn't mention that, but also Core.Async, like the concurrency primitives that we've seen before, async wait, also works on the browser with a slightly different implementation because that is single-threaded. Core.Spec, last thing I want to see, so it's the latest incarnation of the problem of adding or adorning Clojure with types. And this lets you specify domains. It can also do, even if it's not formally, it's not formalized in any way, but it can also do dependent types because you can express types that are dependent on values, if that is the definition. I'm not sure it's, we can do a little demo, but probably I'll just leave it with the example here on the top. But what happens with Core.Spec, and I saw this happenings already a few times, also like in my normal job, is that there are problems that are very well, that I can start really well by describing the domain I'm in, and then from that domain, I can start writing the code that obey the specifications I've written. And this is also giving me generative testing, quick check-like, which is quite useful kind of testing. What's next is not like, this is not an official statement or opinion of the Clojure community or anything like that. It's just mostly what is interesting me, and it might be like a good thing, a good problem to tackle in Clojure in the future. GraalVM, you might have heard of that, is a work of an ongoing work by Oracle to create a new hotspot compiler, and it's going to be much more optimized, and it's already giving very good results. We don't have a Clojure implementation on GraalVM, so somebody's started working on that and then abandoned. So there's space for that. It would be nice to see something in the formal verification space, STM solvers, and stuff like that. Instead of like shelling out to the free or other STM solvers, why not trying to implement it, giving an implementation in Clojure, and see if it's better, how it goes. Deep learning AI, we got a few we got a few neural networks implemented in Clojure already. Cortex is one of them that came to mind. And there's a lot of effort being spent in that space, hopefully more. Sometimes I'm still wondering if we had a killer app, if we didn't, why we haven't, and if we need one. Like, you know, often we think about Rails as the killer app for Ruby, that brought Ruby to like huge adoption. I'm not sure we still reached that. Maybe we're still searching for something like that in Clojure land. So that's it. I hope and you got like a good overview of what is available without like assuming that you have to understand all of the code you saw on the slides. But take these slides if you are interested in Clojure and you want to know what tooling is available, and click the links and follow the links to know what is the best tool that are available. And by the way, yeah, that's the book. I'm almost done with this kind of gigantic book, at least for me, gigantic effort of almost 3 years, because I have a full-time job. But it's coming out nicely, I think. It's more than 800 pages at the moment and counting. So you got a discount code on that if you are interested in knowing, like there's a lot of examples in Clojure. It's not a beginner book, I would define it. So go with the joy of Clojure and also buy this book for any reference or more in-depth stuff. Thanks.
Thanks, Renzo. Questions?
Thank you for presentation. Quick question I had with regards to the piece of code you showed, Core.Async. Whenever you spin off a thread, is there a way to kill it prematurely without any sort of polling or anything like that?
Yes, it is.
Yeah.
Yeah.
So is it happens with like asynchronous exception or signals, or how does that happen?
There's all a mechanism. It's all so the thread is going in a pool, so you have that kind of control already. So you can kill the pool, but let's say you don't need to be that drastic. So essentially, it's keeping control. So there are Java primitives when you create threads that let you control the threads and let you delete them. It's not, as far as I know, it's not a 100% sure fact that when you ask to delete a thread, that is going to terminate in a proper way. This is something I remember from my projects. Okay. Might not work 100%. I think it got better in the latest implementations, though.
Cool. Thank you.
Anyone else? I guess it.
Thank you. Come and chat with me if you want.
Thank you, Renzo.